Hello dear students, today I am starting a new topic that is common to all the conic sections that we studied till now. This is called chord of contact. Okay. So, chord of contact we will define for even parabola, circle, hyperbola. So, this is something that is very common and problems are always formulated from this even in JEE Advanced, JEE Mains. So, it is better to read it once. Now, coming to the definition of chord of contact, the straight line joining the points of contact of the two tangents is called chord of contact of the point. See, the straight line joining the point of contact of the two tangents. Okay. So, here in the diagram it will be more clear. This is a conic, the red one, and there are two tangents from point P, PB and PA. So, the straight line that is joining the point of contacts of these two tangents is called as the chord of contact. So, here it is written that AB is nothing but it is the chord of contact of point P, right. Chord of contact of point P, this is more important. Okay. So, now moving ahead, the question states that, or you may think it as a proof, find the equation of chord of contact of tangents done from point x1 y1 to parabola y square is equal to 4x. So, what we will do? We will here the diagram is there. Actually, from point P I am drawing two tangents to parabola, and these two tangents are touching the parabola at points A and B, and when I am joining AB with a line, then that line is called chord of contact of this parabola from point P. Now, what the question is asking is to find the equation of the line AB. Now, think how we will think that to find the equation of AB, we need to get the slope of AB. There are 2 points also given. So, can we think of any way? Okay, one thing can be that we know the equation of tangents to parabola. So, if we find the equation of PB and if I find the equation of PA, okay, so obviously x3 y3 and x2 y2 will lie on that tangents, right, and even x1 y1 will lie on that tangent. So, let us see, let us first start doing. Equation of PB. What is PB? Tangent. So, y1 is equal to 2a into x plus x1. This used to be the equation of a tangent drawn at a point x1 y1, right. Now, here we are drawing the tangent at point x3 y3, right. So, we will change it like y3 is equal to 2a times x plus x3. Okay. This will be the equation of tangent. So, we should delete this one, right. Now, this is the equation of tangent PB. Similarly, we can write the equation of PA. Equation of PA. It will be y2 is equal to 2a into x plus x2, right. Now, see, these are the equation of tangents drawn at point x3 y3 and x2 y2. What can we think is that these two tangents will also pass through the point x1 y1. So, if we substitute the value of x1 y1 here in place of x and y, then it should also hold. So, we can write this as, since x1 y1 is a common point for both the tangents, common point for both PA and PB. Okay, PA and PB. That means PA and PB must satisfy. That means the point must satisfy the point. So let us first put the value y1, y3 is equal to 2a times x1 plus x3, and the next equation we can write it as y1, y2 is equal to 2a times x1 plus x2. Okay. So can we conclude this from this one thing, that y1 is equal to 2a into x plus x1. See what we did, we made one more equation of tangent, and we can say that x3 y3, not the equation of tangent, we actually took out an equation of a straight line from these two equations, and we can say that x3 y3 and x2 y2 both lies on, say, equation 1, then both lies on 1. Can we say this a statement that x3 y3 and x2 y2 both lies on 1? Yes, because see, if we substitute in place of here y3, then we will get this equation y3 and x3, and if we substitute y2 and x2, then we will get this equation. That means this is a straight line, through which these 2 points pass. So now if we see our curve, then this is a straight line through which these 2 points pass. Therefore we can conclude that this is nothing but the equation of our chord of contact. Okay. So equation of chord of contact, I am writing in short, is equal to y1, that is equal to 2a into x plus x1. On the similar lines, an equation of chord of contact for ellipse as well as hyperbola can be derived. Okay. So I can just give a hint that how for an ellipse it can be derived. Actually, take an standard ellipse like this. Okay. Take 2 points A and B, and from A and B draw 2 tangents. Okay, from A and B draw 2 tangents like this. Okay, and then join this line. This is the chord of contact, and give the similar arguments that if this point is x1 y1, if this point is x1 y1, this is x2 y2, and this is x3 y3, then give similar arguments that since this tangent passes through x2 y2, write the equation, and since this tangent also passes through x1 y1, it should satisfy that equation. Similarly, the equation of the tangent passing through this point should also satisfy this, and then we can extract an equation of a straight line satisfying both these points, and we will call it as chord of contact. So this is intentionally left as an exercise for the students, so that you may practice it and understand it thoroughly. So I hope, and similarly you can even, so basically you can even derive the equation for hyperbola. So basically what we are doing, we are just putting the external point in place of in the equation of tangent. So the equation external point was x1 y1, so we will be just substituting the external point here in the equation of tangent. Same with parabola, same with hyperbola. So I think that now you would be able to confidently handle the questions on chord of contact. Thank you. If you find any doubt, then please ask in the comment section. Thank you.